This conference will now be recorded.
Okay, so guys, from my previous classes, I'm explained about linear regression, right? So by the time uh, I'm explained about importance of the performance matrices, how we can able to measure the performance of that particular model. Rajendra, can you please tell me? Am I explained or not? Rajendra, am I explained the performance matrices of the simple linear regression or multiple linear regression? Srikanth, Sai Kiran, okay, I think so. What is happening? I don't know. You guys are not even talking. I don't know what's going on. I mean, are you really getting my voice or not? Where is Praveen? Anji, am I explained
Yes,
the
sir.
matrices of performance metrics of the simple linear regression, like R square, adjusted R square, mean absolute error, mean square error? Yeah, I think so. You forgot about those things. Just reminding that. There is. Hmm. So you can go with any one of it. Okay, so now guys, I just want to explain about, for example, if we have a machine learning, you build one particular machine learning model and that it's a regression. Okay, so this particular situation, I just want to go for performance testing. Okay, like whether the model is good or bad, so we can't say that with one parameter. So the model can be good or bad, it can be performed with some matrices. Those matrices we are calling it's a performance matrices. What are those? So performance metrics. So with help of this particular performance matrix, okay, so we can concluding that the model is good or bad. Okay, from that one, the very first one is R square. The very first one is R square. So with help of the R square, we can come to that how fit, how how good, how fit that particular model. Okay, and how strongly the model is fit. Okay, with our training data or with testing data. So next one is adjust R square. Adjust R square will help you for different purpose. Okay, and the mean absolute error, MAE, mean absolute error, and mean square error, MSC. And the fifth one is root mean square error, root mean square error. Okay, so these are the, like this we have some parameters are there. So these are the basic parameters. With help of this particular parameters, okay, based upon this particular values, we can come to know that my model is good or bad. Okay, whatever the machine learning model you created or you build it, so that particular model is good or bad, that you can come to know with help of the this particular R square and adjust R square. Clear? Is it clear?
Yeah.
Yes, sir.
Yeah. Yes, sir.
So let me go with understanding the one by one. Let me go with understanding the one by one. So my first thing is that it's a R square. Okay, or you can say that say a coefficient of determination also, but usually the people can call it say R square or correlation. Okay, so come to R square, we have a direct formula. The formula is it's 1 minus sum square residual, sum square residual, okay, RSS, nothing but sum square residual by, okay, and sum square total, sum square total. This is the formula, guys. Make sure that you have to remember this particular formula. So this is the value you will be getting in between 0 to 1 only. Okay, if R square is less than the 0.5, 100% model is not good, not good. Okay, if my R square value is more than the 0.5, then my model is good. Okay, if my R square is it's more than 0.8, then the model is very good. Okay, and if maybe it may be equal to 1, then it's a strongly fit, strong, very strong. Is it clear? Like this, if my value of R square is increases, which means that my model performance was increasing. Is it clear? Did you got my point?
Yes, sir.
Okay,
Yeah.
now
Yes, sir.
you might be thinking, what exactly this sum square error? What exactly this sum square error? Let me consider I have the x and this is my y. So for example, my x value is the 1 and corresponding y value, for example, 2. Let me consider something like this. 2, this is for example 4, and for example this is 3, and for example this could be the 6. I have a data something like this. Okay, this is my original data frame. Okay, this is my original data frame. Now what I did with this particular data, I trained with machine learning model. I trained it with ML model. Okay, or else you can say that's a regression. By this time I can get the model. I can get the model. Now what I did here, what I did here, this is the X data, whatever the X data I used over here, same X data. Let me consider same X data. I'm giving for the input for this particular model, and this can be generating the Y predicted value. That means, so here it can be generating some Y values. So here I'm giving the input values. These input values I'm giving to this particular model. Then it was generating some Y values. For example, my Y values are, it's a 2.5. This could be, for example, 4.8. This could be, for example, you can say that it's a 3. This could be, for example, a 5. This could be, for example, 7. I got something like this. Okay, this is the result of, this is the result we are calling it's a predicted. This is thing we are calling it's a predicted. So this is the Y values we are calling it's actual. Now you got it. This is my actual Y values. I have to get this values, but I got this particular values. So the difference between this predicted and actual, that we are calling it say residual. Got it my point? So what is residual? Tell me, what is residual?
Yeah, actual minus predicted.
Residual means actual minus predicted. That we are calling it say residual. So here some square, right? Some residual means what? What is mean that some residual? Some residual means from my first one to, and that means first this is 2, right? And here I got the 3. This is 4, but I got the 5. This is the 6, but I got the 7, right? So from I equal to, this is I value, for example 1, this is the 2, and this, for example, 3. From I equal to n, and this is my Y values that I can consider as the yi. For each and every one I can consider the yi, and so here I got the Y predicted, right? That I can represent it with Y hat. So Y hat of each one. So I just want to do that sum, right? So 2 minus 3 plus, and 4 minus 5 plus, that is my predicted. 357 are my predicted. Next one is what? 6 minus 7. So here what is my residual? 1 plus here 1 plus here 1. So this is my 3. This is what? It's a sum residual. But my question is sum square residual. Sum square residual means, sum square residual means, so by the summation you have to do it square also. You have to apply the square term. Y actual minus predicted whole square. Now tell me, so 2 minus 3 whole square plus 4 minus 5 whole square and 6 minus 3 whole square. Now 1 square plus 1 square plus 1. So here I got again 3 only. So this is the sum square residual. Is it clear my point? Is it clear my point?
Yeah. Yes, sir.
So this is the sum square residual. But my next question is sum square total. Sum square total. Before I calculating sum square total, I have the x, I have the y, and I have the y hat also. Okay, and this is 1, this is 2, this is 3, and this is 2, this is 4, this is 6, and this is the 3, this is 5, and this is 7, right? This is my, this y hat I calculated from the model. This x comma y is my input, that is my data set. From this particular data set I calculated the y hat. Okay, now what I can do, I have to calculate the mean of this one, y bar. So 2 plus, so y bar means it's a mean. So 2 plus 4 plus 6 by 3, how much? 12 by 3. 12 by 3 means what? 4. This is my mean. Okay, so if I calculated the mean, I just plot it, guys. Just I can plot it. This is my x, for my x, for every x, my mean is same, right? So for example, my mean is 4. This is the line is my mean. Okay. Now what I can do now, I can plot the y hat. So this is the 3 here. This is 3, and this is 5, and this is 7. Okay. This is 3, 5, 7. So I just calculated the difference between these two. Okay. So now tell me, sum square total, right? Sum square total means sum of y bar sum square total. Is it really good? I just confirm it. Give me 1 second. Formula, I just need to confirm the formula. Sum square total formula. Yes, my bad. So my bad. Sum square total means this is my y bar, this is my y values, this is my what? Y values. So my y values is here 2, and in this particular situation 4, in this particular situation 6. Okay, I have to calculate the distance between these 2 points, not the predicted values, Okay, so y mean of y minus yi whole square. Now tell me, what is my mean of y? My mean of y is 4, right? 4 minus 2, 4 minus 2 whole square, 2 square, 2 square means it's a 4. Again 4 minus 4, 0 square. Now 6 minus 4, 6 minus 4, 2, 2 square means 4. Now it's a total 8. So this is SST. Okay, now I have the SST, and now I have the sum square residual. Now I can calculate the R square, right? 1 minus sum square residual is 3, sum square total is 8. Now 8 is my LCM. 8 minus 3, 5. So total how much? 50 by 8, 0 point. Tell me guys. 5 by 8, what is the value of 5 by 8? Are you really good at calculations or not?
0.4.
Sorry?
0.4.
5 4?
No, sir, 0.4.
0 point
6 to 5.
6 to 5.
648
2 5.
and
2 5, sir.
25. Okay. 0 point 0.625, right? So when my R square is more than the 0.5, my model is good or bad? Okay. So this is the formulas will be happening. This is the formulas you don't need to remember for every time, but in a Python programming language, there is some formulas are there. The formulas automatically will do it. Okay. But actually internally, this is the thing will happen. I hope you understood, right? So this is fine. Now you can able to calculate the R square. With the help of the R square, we can able to find the how fit my model is good, how goodness of my model. Okay, my adjust R square. When coming to the adjust R square, we can come to here. I have the x1, x2, and x3, and I have the x4, and for example, y. I have the y. I have the data something like this. In this particular situation, my model y, or my dependent variable, which is depending on the x3, x4, x2, and x1. So which is depending on the multiple features. By the time I calculated the r square. Let me consider same way I can calculate at the r square. If I calculate r square, for example, it's a 0.78. Okay. See, if my adjust r square also same, if my adjust r square also same, that means this all features are important. For example, my r square I calculated the 0.78, but my adjust r square it was something like this 0.64. With this particular situation, here my r square is good, but my adjust r square is little variated, which means maybe some of the features are not important. You consider the 4 features. When I consider the 4 features, maybe my model is good, but when I see the adjust r square, maybe it was a little variated when I compare with r square, which means that which is not, this all features are not important. That means this is the y which is not depending on the all features. Okay, so this is that was the thing which is explained by the adjust r square. Now tell me, did you got my point? What exactly the adjust r square? Adjust r square which is giving the importance, which is giving the is there any features are depending, not depending, which it's not finding the which features are depending or which features are not depending, but it is giving the overall model performance. Maybe if we have some features which is not much good, okay, maybe the model is not much good when you're combining these all features. With help of the VA factor, we can able to modify our variance form factor. We can finding the importance of the features. Maybe from this particular 4 features, x1, x3, and x4 are more important or more depending by this y. By the time I calculated the r square is 0.78, 0.85. Maybe my adjust r square also 0.85 or else 0.8.0. So which is approximately same, right? My r square and adjust r square, which is approximately same, right? What exactly this mean is, this instead of these 4 features, if I consider these 3 features also, I'm getting the good model. So I don't need to waste up my time, I don't need to waste up the data, okay, I don't need to waste up my memory. So this is the happening exactly in case of adjust r square. Is it clear? So the adjust r square formula is, my adjust r square formula is, it's a very simple thing, 1 minus, so you already know it, 1 minus r square, you already calculated the r square, so r square 1 minus r square into n minus 1, n minus 1 in the sense number of records, if you have the previously here I have the 1000 records are there, then you have to consider as the n is my 1000, okay, and n minus p minus 1, p minus 1 in the sense number of features, so here my y is depending on the 4 features, right? So here my p is the 4, so r square you have to calculate it, r square we have to calculate it, but n minus p, what, n minus p which is depending on the data, you know it, r square, okay, n is number of records, p means number of predictors, or you can say that features, predictors, okay. So previous example only we can consider, my r square is 0.65, right? 1 minus 1 minus 0.625, and I have the 3 features only, 3 minus 1 in the sense 2 by, I have only one feature, right? So 3 minus number of predictors only 1, okay, by this time 1 minus 0.5, how much? It's a 2, so this overall will be 1, okay, 3 minus 2, it's a 1, right? So 1 minus 0.625, what is the value of it? 0.375, 0.375 into 2, yes, so So 1 minus 2 into 3, 7. Tell me, guys. 10, 14, 15, 15, 6, 7, 7. 0.
7.5.
Hmm?
7.5.
7.5, right? So 1
Yes.
minus 7.5. 1 minus 0.75 means it's 0.35. Okay. So it is not much good model. Okay. Like this, we can able to calculate it. This data is very small, right? That's the reason we are getting that value. Okay. So very not similar data we are getting, but that's exactly the process. Okay.
0.25.
Yeah, whatever it is, just casually I'm telling it. Okay, that is the process. That could be the process of calculating the r square and adjust r square. Okay, now you know the y and you know the y hat. So my y is, for example, 2, 4 and 6. My y hat is, for example, 3, and this is 5. This is, for example, 7. Okay, so now I just want to calculate the mean absolute error. Mean in the sense 1 by n, number of records. Mean means what? Summation. Oh, sorry. I am calculating the MAE, mean absolute error. Absolute means what? Modulus y hat. But mean, right? Mean means what? Sum, and meanwhile you have to apply the total by the total number of records. Y equal to n. So by this time I have the 3 records are there. 1 by 3 into y minus y hat. So y minus y hat in the sense actual minus predicted. So 3 minus 2 minus 3, it's a minus 1. So minus 1, right? But I'm applying the modulus, right? So that it's a 1 only. But plus, because of the sum plus, 4 minus 5, it's a 1. 6 minus 7, it's again 1. So now what I can calculate it, 3 by 3, how much? It could be the 1. Mean absolute error is, it's a 1. So that means the error rate is very small. The error value is very, very small. Okay, then you can able to go for calculated the mean square error. Mean square error in the sense 1 by n only, but you just need to go with same thing, y minus y hat whole square. Okay, so here 1 by 3, so 2 minus 3, 1 square means it's a 1, plus 4 minus 5, 1 square means it's 1, 6 minus 7, 1, 1 minus 1 square means it's a 1. Again, mean square error also we got the 1 only. Root mean square error in the sense, we just need to apply the root of it. We just need to go for apply the root of it. Root mean square error, which means square root of 1 by n sum of y actual minus predicted whole square. So by the time here we calculated the 1, right? So square root of 1 means it's again 1 only. So this is the parameters. These are the parameters will help you to find out the performance of the model. Okay, to check the performance of the model, what we created. Okay, that we can able to calculate it with the help of this particular features only. Is there any question, guys? Is there any questions regarding about this one? Tell me. Okay, now I am come up with some more important things. When you are working with a machine learning model, you need to remember the variance and bias. Variance and bias. Okay, so variance also it's a error only, and bias also means it's error only, but error with testing data. testing data. That we are calling it say variance. And bias means this is also error only, but after you building the model, I just need to go with finding the error with the training data. Just need to remember these 2 points. Okay, so you have a model, right? Let me consider I have a data. So usually the data, maybe the client can be providing the training data, test both can be providing training and testing. Some situations the data it could not provided by the project manager. Training data, testing data he could not provide it. So I can split my entire data into 2 parts. One is the training, one is the testing data. So 80%, 70 to 80% I can consider the training data, and 20 to 30% I can consider the testing data. So with this particular training data, what I can do, I can apply the machine learning model, I can train it and I can build it. So this particular machine learning model, I can calculate the model, right? I may build the model. Okay, by this time, with this particular training data, again I can use it for testing. Okay, again I can use the training data to this particular model. I can calculate the error. So for example, here I have the y training data. Okay, so here I can calculate, I got the result is y trained predicted. So here I can calculate the difference between or error between this y predicted and the original y trained data. So that error we are calling it say bias. Okay, so same test data I can use for the model performance. By the time here y test is my data, here I can get the result is y predicted. So I can find out the difference or error between these 2 things, then that we are calling it say variance. Now you got it, what is variance and what is bias? Tell me guys. What is bias and what is variance? Did you got it my point? Please speak out so that I can get the energy. Otherwise I could not. Tell me guys, did you got it my what is exactly variance or what exactly the bias? So with these 2 parameters only, my model performance also you can test. So that means there is a 2 type of errors you might be getting. One is the overfitting, and second problem you might be getting when you're applying the machine learning algorithm. So you might be getting the 2 machine learning problems. One may be overfitting and second one is the underfitting. Okay, so overfitting means, so with my training data, less error. With training data, less error, but okay, but with test data, high error. With the test data, you might be getting the high error rate. Same thing you can call, or same thing you can describe the definition. So with low bias means what? Error with the training data, right? Low bias with high variance. That is also correct only. Or some people can describing something like this. Overfitting, some people can be describing something like this. Good model with training data with training data, but bad model with test data. Bad performance, nothing but bad performance of bad model. Bad model with test data. This is what overfitting. I hope you understood, right? So if you're getting the overfitting problems, that means the model is not good. Even with the training data, we are getting the good performance. But when you're applying some new data, so you might be getting some less performance. Okay, so that is exactly the overfitting. Now let's go with understanding the underfitting. Underfitting means low bias, low variance. Low bias and low variance. Oh, sorry, it's my bad. High bias and high variance. High bias and high variance. That means the error rate will be the error rate is high with the training as well as testing. The error rate will be the high with the training and testing. So that kind of situation we are getting the problem is underfitting. So when the model, you're facing the problem of the underfitting and overfitting. When you're facing the problem of overfitting and underfitting, to solve that one, we have the two algorithms are there. That one is a regularization. Usually the people can call it a regularization. Regularization. So regularization is the technique. Regularization is the technique. There is two type of regularizations are there, L1 and L2. So L1 regularization and L2 regularization, these are the concepts, or you can call it's a ridge regression and lasso regression. You can say it's a ridge or else lasso. So these are the two techniques, ridge, lasso. Same name you can call it's a L1 regularization or L2 regularization. With the help of these two techniques, we can solving the overfitting problem or underfitting problem. Okay. Now is it clear my point? Can you confirm me? Did you got my point or not?
Yes, sir.
Yes, sir.
Okay. Pretty cool. And so this is for today's class, guys. Tomorrow we'll try to go for understanding the ridge regression, lasso regression, and with one practical example. Both we will see by tomorrow's concepts. Okay. Yeah. Thank you, guys. Bye. Take care.